All right, this is your review, guys, for sections 9.4 and 9.5 quiz tomorrow. This is your review. We're going to do 10 problems. The first problem is 8/10, and we're converting that to a decimal. Okay, we do that by looking at the denominator, okay, like I just said, looking at the denominator, and if that is one of my place values, which, does everybody agree, the 10th place is a place value, I can just put that number in that place value, 0.8. 0.8. All right, now on number 2, I want you to change this fraction to a decimal. All right, is there any such thing as the 25th place? No, so there's something you can do to get your denominator to be one of those place values, and then you can write it as a decimal. You will have to show this work. All right, so number 1, there's no work to show because the denominator was already one of our place values. Number 2, there's some work I need to show. All right, what would it take to make 25? Well, let me ask you this way. What denominator do I want to have in this scenario? 100. Okay, so 25 times what equals 100? 4. 12 times 4 is 48 over 100. And now that my denominator is one of my decimal place values, I can simply put 48 in the hundredths place. And that's my answer. All right, what about this one? What about this one? There's actually 2 methods of converting a fraction to a decimal. Okay, now this method that I have to use here is a little different, but there's a reason I can't multiply it. Can I multiply 9 times anything to get it to be one of my place values? No. So what do I need to do? Long division. 7 divided by 9. All right, go ahead and do this. Does 9 go into 7?
No.
Nope. So out of 0, 9 didn't go into 70?
Yes.
How many times?
7.
63, and look at there. I got another 70, 7. And got another 70, 7. So what's repeating?
7.
0.7 repeating. Who got it? 0.7 repeating. Awesome, okay? So first section on your quiz tomorrow. Second section on your quiz tomorrow works in the opposite direction. Converting a decimal to a fraction. So if it's a terminating decimal, that means I can directly put it into a fraction. I don't really have to do much anything else. All I have to do is identify what is the last place value in my digits. What is the place value though? The hundredths place. So it's 100 in the denominator and 72 in the numerator. And then I can reduce it. You can use your calculators to reduce, guys, but you have to write this. Your calculator won't give you this. So if you try to skip this step, you're going to lose your points because then I just think you use your calculator to solve. So 72 over 100 shows me that you understand it's in the hundredths place, which is the same thing, and then you reduce it. 18 over 25. Okay? You think you guys can do one? All right, 0.96, convert it to a fraction. Make sure it's fully reduced. So what's my fraction? What's the first fraction I write?
96 over 100.
Yes, 96 over 100. You've got to have that step tomorrow, then reduce it. 24 over 25. What if you had a repeating decimal? Now this one, guys, this is the one that's literally going to take up the rest of the page. Okay? But step by step, we can follow the steps. I just want to see how much of it you can remember. Okay? So I'm not going to give you a whole lot right now. I want you to try to just do it. Some of you might be able to get all the way to the answer. Some of you might just need a few refreshers here or there, and that's what this is for. That's the first thing you need to do. Just tell me. No. Put it into an equation. X equals 0.64 repeating. Now I have to multiply both sides by some number. 100. Why is it 100? There are 2, not the hundredths place, 2 digits repeating. So there might be only 1 digit repeating in the hundredths place, and then I would multiply it by 10. Okay, so how many digits are repeating? 2, so multiply both sides by 100. 100x equals, okay, now what happens when I multiply a decimal by 100? What happens to my decimal?
Oh, the decimal moves right.
Yes, it moves right 2 places. Okay? Now, let me ask you this. What comes after this? Is there zeros that come after the 4? No, there's 6, 4, 6, 4. So when I move that decimal, it becomes 64. Hold on, I want to get rid of that arrow. 64.64 repeating. So I'm still stuck with that repeating. That's what I'm trying to get rid of. Now, something happens next, and it's not divide. You subtract something.
Subtract x and then subtract 0.64.
Yes, subtract the original problem. Minus x equals 0.64 repeating. Okay, now here's what happens, and this is my whole goal in why I set up this equation. If I have 6,4 repeating minus 6,4 repeating, that cancels out the repeating part. So now that's why it goes away. That's why I erased it, because the repeating part cancels out, and now it frees up those numbers to be subtracted from each other. So what's 4 minus 4? 0. What's 6 minus 6? 0. So what's 100 minus x? 99x equals 64. Now I just have one more really simple step, and what is that? Divide by 99. Okay? It cannot be reduced. 64 over 99. And guys, one way you can check this on your quiz tomorrow, put this fraction in your calculator. Put the fraction in your calculator. 64 over 99 equals, and hit S to D. Hit S to D. Point what? 64, 64, 64. And then, oh wait, the last number is a 5. The only reason it's that is because it rounded it. Okay? All right. Number 7, 8, and 9. Are these numbers rational or irrational? Are these numbers rational or irrational? But you can't stop there. You need to categorize them. So I even have it written on the board. Rational numbers. Okay, so it won't be on the recording, but you can just listen. Rational numbers are terminating decimals, repeating decimals, integers, and whole numbers. Okay, now those are my categories. So irrational numbers are non-terminating and non-repeating. And guess what, guys? Those categories make up all the numbers in the known universe. All the numbers in the universe fit into one of those categories. So when you say this is rational or irrational, it will fit into one of those categories. Okay? All right, so go ahead and solve 7, 8, and 9. Again, check your answers. You need to get your answers first, okay? And check your answers with your group mates. First one, because I only have 3 decimal places, there's no repeating bar, there's no dot, dot, dot after it, I know that it is a rational number because it is a terminating decimal. Okay? Now, the cubed root of 49, when I put that in my calculator, I get a very, very long decimal value, and that would constitute it as an irrational number. Non-terminating, non-repeating. What about 10? Rational. Whole number. Technically, it's also an integer. And I would accept that. Number 10, I want you to approximate the square root of 67 to the nearest integer and the nearest tenth. To the nearest integer and tenth. And remember on your homework. So I looked at your homework. Most of you guys did this. On your homework, you needed to show me the perfect square that it was closest to. And that's your work. Okay, so make sure you do that. All right, guys, what is the perfect square that is less than 67? 64. Then you have 67, which is the one you're doing. Then which one is greater than 67? 81. Okay, which one is it closer to? Obviously, 64. So it's approximately 8. And then 8.18 rounds to 8.2. All right. So that should help you in your review for your quiz tomorrow over 9.4 and 5.